I know. I don't know why it says that. I erase it every morning before I bring it in, so it's just one of those things that it pops up for some odd reason. Okay, so if we factor out the x, we can do the same thing here, where we can just factor out e to the x. Okay, so if we factor out an e to the x times e to the x will give us e to the x squared, so that's just e to the x here. And e to the power of x times -1 will give us our minus e to the x. E to the x minus 1 equals 56. Okay. Now there are actually two different ways to do this one. This way is somewhat different, but the easier way would probably be to just use regular ordinary factoring. But we can factor. Okay, so let's say if we decide, instead of using that form, we say e to the power of x squared minus e to the x equals 56. Let's say we subtract 56 from both sides. Okay, so we have e to the power of x squared minus e to the power of x minus 56 equals 0. Okay, so now just temporarily replace our our e to the power of x with y or x or anything else. So temporarily replace e to the power of x with y, or any other variable you want to use. Okay, so that means that will give us y squared minus y minus 56 equals 0. Now that form is a little easier to solve. Okay, now here we just have to find two numbers that multiply to equal our c, and those same two numbers add to equal our b, which in this case is -1. Okay, so we know 8 times 7 is 56, but by this being negative, 1 would have to be negative. So we know here that the largest number is negative, so we have -8 times +7, and -8 plus +7. Okay, so we know that this factors to become y minus 8 times y plus 7 equals 0. Okay, so we know we set both of those equal to 0, and that will give us y equals 8 or y equals -7. Either one of those will make that true. Okay, but remember we temporarily replaced that e to the power of x, so we just have to change it back. Okay, so e to the power of x can equal 8, or e to the power of x can equal -7. And it's just one or two more steps, but I don't want to have to try and squeeze everything on here, so I'll continue that on the next page. I'll leave that up for a few more seconds. All right. write down where I left off. Okay, I'm still writing. It looks like everyone's done writing. Okay, so we know that e to the power of x equals 8 or e to the power of x equals -7. So in order to solve for x, once we get our e to the power of x, we just apply natural log to both. Okay, so we'll apply our natural log. That means we have the natural log of e to the power of x equals natural log of 8, or natural log of e to the power of x equals natural log of -7. And again, those two will cancel each other out. So you have x equals natural log of 8. Or, again, those two will cancel each other out. So you have x equals natural log of -7. Okay. But if you remember, natural log, let's say, I'll say of m, is equal to log base e of m. And one of the properties of our log function is that m actually had to be positive. Okay, so this one you can't use it because it would have to be positive. Now the solution, since natural log of m is only true when m is greater than 0. Okay, so this one is actually not a solution. So natural log of 8 is your only solution. All right, so any questions on that one? All right, I'll leave that up for a few more seconds. Excuse me. Looks like everyone's done writing. All right, so now we're actually going to apply these two story problems. And if you remember, a equals p e to the power of RT, that's your formula for exponential growth. And a equals p times e to the negative RT, that's your formula for exponential decay. All right, so what if we wanted to solve the problem where you have a sample of bacteria is growing at a rate of 8% per hour. Compounded continuously. So how many hours will it take for the sample to double? All right, so first, we already know it's going to be exponential growth. So that's the formula we're going to use. Okay, so we know A equals P times E to the RT, since we're looking at growth. Okay, so we know that our P, remember that's our principal or starting value. Okay, thing is they never told us how much bacteria we started with. So we're just going to let that equal our unknown, which is X. Okay. Now our rate of growth is 8% per hour. So our rate is equal to 8. Okay. Now the amount after time t, we want to know how long it would take for the amount to double. So that means in order for it to double, it would have to be 2 times whatever we started with, which we don't know. So we'll just make that 2 times x. Double what we started with. Okay, and we know that our time, that's actually what they want us to solve for, how many hours. So that's what we need to solve for. Okay, so we have everything we need right here. Okay, so our A is equal to P times E to the power of RT. Our A is 2x. So that's 2x is equal to our starting value, which we don't know, times x times e to the power of RT. So that's power to the 8 times t, since we don't know what t is. Okay. So once we have everything figured out, we just plug it right in. First thing we have to do is get our exponential factor by itself. So we divide both sides by x. And that gives us 2 equals e to the power of 8t, or e to the power of 8t equals 2. You don't have to flip it around like that. I just feel better when I'm solving for the left-hand side. Okay, so just like before, we have our e to the power of something. Okay, and just like before, we have to just apply natural log to both sides. Okay, so that gives us natural log of e to the power of 8t equals natural log of 2. All right, so we know that our natural log and our e always cancel each other out. So those two cancel each other out. which leaves us with 8t equals natural log of 2. Divide both sides by 8. We have t equals natural log of 2 over 8.